Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
OSPF neighborship states. Will start. Then in it, tell me. Two-way.
Extra.
Exchange.
Exchange. And finally full. So there is down state, attempt, init, two-way, access start, exchange, and loading, and full. We must understand the role of each state, and we must have this information, because in sometimes what happens in interviews also, they can ask you about OSPF neighborship states, and I hope that some of you, if some of you have already gone through some interviews of networking, then might be you face this type of question. Are you attempted your interview before? Not yet. You? They asked about switching only, huh? Fine. Down. Down state means it is not doing anything. Neighborship is now down. In down state, it won't do anything. It won't perform anything. It will not send any packet, will not receive any packet, nothing. Attempt. What? Yes. In OSPF, if you have configured your neighbor statically, then only attempt state can be there. If you have not configured your neighborship statically, then you will never find this state. It's not like that you will find it in frame relay only, no. Even you can also find this state on Ethernet ports too. You can also find this state on point-to-point serial link too. But the problem is, like, to see it, you must configure your neighbor statically. So if you have configured your neighbor statically, then of course your neighborship will go through attempt state as well. And in attempt state, actually it sends unicast hello packets. The meaning by attempt state is that it have not received any hello packet from its neighbor, but it have transmitted unicast hello packet. Init, initialization.
It's not receiving, it is sent.
What attempt? It has sent only. In init, it means you have received hello packet from the neighbor. The meaning by init initialization is what? That you have received hello packet from the neighbor. So in OSPF, if you have received any hello packet from your neighbor, it means it is in init state. You have received, but it is not confirmed that whether your hello was delivered on neighbor or not, but you have received it from the neighbor. But you don't know about your own hello, that whether it is delivered on the neighbor or not. So in somehow you can say that you have received hello packet from your neighbor, but you have not given it to your neighbor. So if you have not given hello packet to your neighbor, but if you have received hello packet from your neighbor, it will be known as init state. Two-way means that they have exchanged their hello packet. And how will we come to know that, okay, hello messages have been exchanged? Neighbor. In hello packet, I hope that you remember, in hello packet we were having last field, which was neighbor router ID. So what happens actually, that let's say that I have received one hello packet from my neighbor. Now it means that I have came to know my neighbor's router ID. So whenever I will send hello packet back to that neighbor, in that hello packet I will specify that what is the neighbor router ID. So whenever my hello packet will be delivered on neighbor, that neighbor will get its own router ID in the received hello packet. Let me show you in this manner. This is router 1, router 2. So you can ping from R1 to R2. Fine. Let's say R1 have given one hello packet and it didn't receive anything from R2. So in that field, like neighbor router ID, it will specify, because it have not received any hello packet from the neighbor. It has transmitted this hello packet to R2 now. But on R2, let's say OSPF was not enabled. You first enable OSPF on R1. So once you enable OSPF on this interface, immediately it started to send hello packet. But because before now it didn't receive any hello packet coming from any neighbor, that's why inside the neighbor router ID it will specify 000, and then it will send this hello packet in the direction of R2. R2 will receive it, but let's say that on R2 you have not received you have not enabled OSPF yet. So if you have not enabled OSPF on this interface of R2, let's say it was Ethernet 0 and this was also Ethernet 0 on R2. So let's say that if you have not received hello packet on R2's Ethernet 0, you have not received actually. You have received hello packet on R2's Ethernet 0 by 0, but it will not accept it. You know why? Tell me why? Because OSPF is not enabled on this interface yet. You just enable OSPF only on R1. And if you have not enabled OSPF on R2's Ethernet 0, till that it will never listen for that group, which is 224.0.0.5. Without enabling OSPF on any interface, your interface cannot accept packets coming for that multicast address used by OSPF, like 224.0.0.5. So whenever this R2 will receive this packet coming from R1, it will discard it if you have not enabled OSPF. Once you will enable OSPF now, this interface will start to receive those packets which are coming for group 224.0.0.5 as well as .6. But .6, for .6 it will activate whenever it will become DR. Fine, forget about it. Let's say that it is accepting packet for .5 only. So now let's say that R2, now you enable OSPF on R2 as well. Whenever you will enable OSPF on R2, R2 will immediately also send a hello packet in the direction of R1. But this time, will it specify but this time this R2, will it specify the router ID of R1 in this hello packet? No. You know why? Because when it received the previous hello packet from R1, OSPF was not enabled on this device. So it didn't understood that packet at that moment. So whenever this time this R2 will send this hello packet in the direction of R1, this time too it will specify its neighbor router ID as 0.0.0. You see that both of them have exchanged hello packet with each other, but still it is not two-way state. It is known as init state. See, if you have received any hello packet from your neighbor without your own, like let's say R1 have received one hello packet from R2, but in this hello packet it didn't receive any neighbor router ID. In neighbor router ID, R1 didn't get its own router ID. It is known as init state. Now, because R1 will accept this hello packet, so this time whenever R1 will send this hello packet back in the direction of R2. Because this time, let's say the router ID of R1 is 1.1.1, on R2 it is 2.2.2. So this time, in neighbor's router ID, R1 will specify 2.2.2. So whenever this R2 will receive this packet, this hello packet coming from R1, it will open this hello packet and will check its own router ID. And it will find its own router ID. So it will be known as now two-way state here on R2. When R2 will send next hello packet to R1 now, because this time R2 have received hello packet coming from R1. So in this hello packet, it will specify neighbors router ID as what? So this time R1 will get its own router ID in received hello packet, and once this router will start, once any OSPF is speaking router will start to receive hello packets with its own router ID, it means your neighborship has moved into two-way state. Means now they have exchanged their hello packet with each other. It has confirmed now. So this is the meaning by two-way. I hope that now you have separated or you have understood the differences in between init state and two-way state. In init state, in received hello packet, you will never find your own router ID, but in two-way state you will always find your own router ID in all received hello packets. Then after in two-way state, it will also perform some other tasks too, such as DR and BDR election, and this DR and BDR election will be depending only on network type. Are you getting my point or not? If your network type is like point to point, because I will also discuss all these network types, that in which network type DR BDR election will be performed or in which network type DR BDR election will not be performed. So I will be discussing it with you. But now remember that if DR BDR has to be elect, then DR and BDR election will always be performed during two-way state only. Understood or not?
Yes.
Cool. So DR BDR election will also be performed in two-way state. Fine. Now it will move into X start state. And remember that till two-way state they will exchange only and only hello packets, not DBD. Till now you have not used DBD packet. Now after two-way it will move into X start state. And in X start state, you know very well that what will happen. They will elect master and slave. There will be an election in in X start state of master and slave, or you can say master slave election will be performed during X start state. And also they will negotiate the sequence number of DBD packets too. They will also negotiate the sequence number of DBD packets too. Now what is the role of this sequence number inside the DBD packets? I'll be discussing it with you, don't worry about that. During practicals again I will teach you that okay, this is the reasons that we are required to negotiate the sequence number for their DBD packets, right? So remember that in X start state they will perform two tasks now: master and slave election. Second, sequence number negotiation for DBD packets. Are you okay with it now?
Yes.
Fine. And remember that master and slave to elect master and slave too, they will send DBD to each other. It does not mean that they have not exchanged DBD packet in X start state. Even to elect it master and slave, they are sending DBD packets to each other. But remember, DBD packets exchanged in X start state will never contain your LSA information, your update information, your routes information. Only sequence number and master and slave negotiation will be done with the help of those DBD packets. Means that in X start state, routers or two OSPF neighbors, two OSPF speaking routers will exchange blank DBDs. We call them as blank DBD. So in X start state they will exchange blank DBD packets with each other so that they can perform master and slave election, as well as they can negotiate their sequence number for DBD packets only, because in future they will exchange DBD packets with each other. So for each DBD packet they must have sequence number. I'll let you know that why is it necessary, why is it mandatory to have DD sequence number, database descriptor sequence number. So this DD sequence number will be negotiated during X start state, and also master and slave election will be performed during X start state. So for doing that, they will be responsible to send blank DBD messages to each other. Yes, fine. After it, So basically in access start state, from access start state itself, they have started to send DBD packets to each other now, right? Then they will move into exchange state. Now you know very well that in exchange state, they will exchange actual DBD, not database. Actual DBD, still it is having description only, not database. Only description, not complete database, right? Do not learn it in that way that okay, in exchange state they will exchange their database. No, they will simply exchange only DBD information, DBD packets. In exchange state also they will exchange DBD packets, but this time they will not exchange blank DBD. They will exchange DBD with LSA information, with update information. Are you getting my point or not? So still in exchange state 2, they will exchange DBD packets with each other, but this time inside DBD they will be having their routes information. Then they will move into loading state. And if you talk about the loading state, in this state they will exchange actual database. Means in this state they will be using three types of messages: LSR, LSU and ACK. Because to get an update we have to send first request. To send request it has to use link state request LSR message. And when a router receives a LSR message, then in the response of LSR it has to give LSU link state update. And when a router receives LSU link state update, then it has to provide LSAC in the response of LSU. Understood or not?
Yes.
So all these three types of messages will be used
In loading.
in loading state. Have you understood it now or not?
Yes.
Fine. Finally, it will be full. Full means they have synchronized their database successfully. Meaning by full state is what? They have synchronized their database successfully. Synchronized means they have exchanged their database, their information with each other successfully. This is the meaning by full state. Now, sometimes your neighborship will stuck in two-way state. So there are, due to which reasons or due to what your neighborship can stuck in two-way state? Tell me. But after all, it will move into full state. If DRBDR election is there, say in between two DR other routers, in between two DR others, your neighborship will always stuck in two-way state. Is there anything else, or is there anything, any other thing so that your neighborship can stuck in two-way state apart from it?
Maybe by chance if we don't discuss the router ID.
No. If router ID is same, then it will not.
If we don't receive the router ID of the neighbor routers.
Then it will be in init state.
Okay.
It will not be in two-way state. Fine. Okay. Remember that this is the only thing in which your neighborship can stuck in two-way state, where you are going to form neighborship in between two DR other devices, DR others, right? So in between two DR others, their neighborship will always stuck in two-way state. Next is what? Access start. Sometimes you will also find that your neighborship will stuck in access start state, and it will happen due to MTU mismatch. So if your MTU is mismatched, then it will stuck in access start state. Next is sometimes what happens that your neighborship will move into exchange state and then will come back to init or something like that, right? Like two-way state and all these things, right? So it can happen due to, like for an example, you are having more than 3 routers in a single multi-access network. So there must be DRBDR election in OSPF, right?
Yeah.
But what you did, you configured their network type as point-to-point on all these 3 devices. So on all those 3 devices, because you have configured your network type as point-to-point, so whenever they will flood their LSS information, their updates, so they will perform too much flooding, right? And if there is too much flooding, then again your neighborship will move back from exchange state to down, and your OSPF will reinitialize its neighborship once again. I am saying that even we will prove it, that if you are having more than 2 routers in a multi-access network, like 3 routers, do one thing, move on all those 3 routers and configure their network type as point-to-point. So there will not be any DR and BDR election. Do not configure their priority as 0, because you also know, because you can use your brain as well, and you will think that, okay, sir said that, okay, configure their network type as point-to-point, so that they will not elect DR, BDR. So you will think, okay, if we configure their priority as 0, even you are using network type as broadcast, so that also they will not elect their DR, BDR. But the thing is, if you configure if you keep their network type as broadcast, and if you have configured their priority as 0, the only thing that will happen that they will not participate in DR and BDR election, so they will work as a DR other, and in between 2 DR others, their neighborship will always remain in two-way state, right? So it will never be performing. This kind of problem cannot occur if you are having your network type as broadcast, and even if you have configured their priority as 0 too. But if you want to see that kind of problem, then do one thing: in a single multi-access network, connect more than 2 routers, and then on all those 3 routers or 4 routers, configure their network type as point-to-point. So there will be too much flooding of LSS, and if there is too much flooding of LSS, then also your neighborship will stuck in. It will move up to access start state, and again it will come back to down state and again reinitiate your neighborship. We can see that. We will see that actually. Loading is also there, full is also there. Sometimes what happens that your neighborship will be in full state, but still routes will not be available in your device's routing table. It can happen due to mismatch of network types only. Sometimes what happens that network type will get mismatched, but still they can form neighborship, but they will not be able to install those routes inside their routing table. Okay, so I have discussed all states now with you. So I have taught you that what will happen in which state, right? So I have taught you everything, the possibilities of all neighborship states, OSPF neighborship states, and all these things, right? So I hope that now you can easily perform troubleshooting and all these things, right? Fine. Now after talking about it, like neighborship states and types of packets, we have understood that what are the uses of all these types of packets available in OSPF and all these things. Let's talk about loop avoidance mechanism used by OSPF, right? Loop prevention mechanism to avoid, loop prevention mechanism available in OSPF. So there are some, you can say, techniques in OSPF which are used to prevent your network from routing loops. Here we are not having split horizon. Do you remember that in RAP and EICRP, in both of them we were having split horizon, but in OSPF we do not have the rule of split horizon. You know why? Because all routers will maintain a complete topological database. Here in OSPF they will not exchange only best route information. They will exchange their database table. So that is why here we do not have any rule of like split horizon and all. So here in OSPF for loop prevention we are having some other characters such as sequence number of LSA, because you know very well that updates will always go from one device to another device in the form of LSA, link state advertisement. I'll be discussing it with you later on, that how many types of LSAs we have in OSPF and how do they looks actually, what are the fields available inside the LSAs, all these things. Second, checksum. Third, edge. What? In OSPF it will never use split horizon. It has some rules same as split horizon, but here we do not have split horizon under interface mode. There are some certain rules which work same as split horizon. So I hope you have understood these 3 things, like sequence number of LSA would be used to prevent your network from routing loops. Checksum will also be used to prevent your network from routing loops. Edge will also be used to prevent your network your networks from routing loops. How can a loop occur in OSPF if you are not using sequence number? Try to understand now. Hello. R1, R2 is there, R3, R4, R5. There was a network behind R1, 10.1.0/24. R1 will give this update to R2 now. R2 will learn it via R1. Then R2 will give this information to R3. R3 will give this information to R4 as well as R5. You understand? Are you getting my point or not? So this time do one thing, just make some changes here as well. Let's see, this is R6 and these are also serial links. So this time R3 will give this information to R4 as well as R5. Now in between R3, R4, R4, R6 and R6 and R5, we are using slow links, serial links. In between R3, R5, R3, R2, R2 and R1, we are using Ethernet links. So the bandwidth of Ethernet links is too high rather than serial interfaces. Fine. So R1 will give this update to R2, R2 will further give this update to R3, R3 will give this update further to R5. So for R5 it will be something like this, that to reach 10.1.0/24 it will go via R3. R3 will give this update to R4, R4 will give this update to R6 and R6 will give this update to the R5. You understand? So R5 has installed this information now. Now let's say that this network has gone down. It will tell to R2, R2 will give this information to R3, R3 will give this information to R4 as well as R5. Let's say R5 have removed it now because this information has gone down and this update is still on the way. Now R4 will give it to R6, right? Now immediately this interface have came up once again. It will give this information to R2, R2 will give this information to R3, R3 will further give this information to R5. That right? But let's say that R6 have given now old update to R5 now, that okay, this network has gone. So R5 will think that okay, now this network has gone, so it will remove it. However, you can see that this network is still up. So due to low bandwidth, it can happen in your network. Due to low bandwidth, it can happen in your network. So again, you can see that in OSPF also there are some possibilities that routers can also install some incorrect information inside its routing or inside its database table. And if there are some possibilities in which OSPF can also install some incorrect information inside their database table, it means there will always be some possibilities of routing loops as well. Try to understand it. R5 installing incorrect information inside its routing table, right? So if there are some possibilities to install incorrect information in the database table of OSPF, it means that there will always be some possibilities of routing loops too. Fine. Now we are having here the concept of sequence number now, and in OSPF the sequence number of LSA, this is not the sequence number of DBD. Remember, this sequence number is not of DBD packet. The sequence number will be of your LSA itself, your link state advertisement itself, right? So sequence numbers in OSPF will always start from 0x 0 0 0 0.
The 0x8.
Yes. 0 0
15 0.
1. and will go up to FFFF. Remember that if your sequence numbers have reached its maximum limit, however, to reach this limit, it will take years. And if you are changing their sequence number, if you are making frequently changes, then also it will take years. Otherwise, it will never reach this highest value. But the thing is, if it reaches its highest value of sequence number, it will reinitiate your neighborship and will allocate its sequence number from 1. It will resync neighborship and also will start to allocate sequence number from 1. Fine. Now, if you are using sequence number, let's say that this interface was up, so it allocated sequence number 1. R2 received it with sequence number 1. R3 received it with sequence number 1. R3 have given this update to R4 as well as R6 with sequence number 1. So R5 was installing this route as like this via R3. Now this network has gone down, so it will say that okay, it has gone down with sequence number 2. It will give this information to R2. R2 will give this information to R3 with sequence number 2 that it has gone down. So once again, now R5 will remove it from its routing table that it has gone down. Now in case if it comes up immediately, then it will give this update with sequence number 3 to R2 as well, with 3 to R3 as well, with 3 that it have came up. R3 will give this information to R5 that okay, it have came up once again, so it will install it immediately via R3, is not it, with sequence number 3. Let's say now R5 has also received the older update coming from the direction of R6. With sequence, it will come with sequence number 2 that this network has gone down, but this time this R5 is not going to accept this information because it received this update with lower sequence number. So if any router in OSPF receives any update with lower sequence number, it will never accept that update. It will simply discard that update because it came with lower sequence number. So in this way, you will always use the sequence numbers in OSPF during the updation, during giving update to their neighbor devices. Sometimes what happens that your link will not go down, but still there are some possibilities in which also there will be some changes inside your LSA. So if some changes are there inside your LSA, then it will change its checksum value as well as age timer. So let's say that I was having a LSA with age of 1000 seconds, and now I received another LSA with lower age, then I will accept that, because if LSA is coming with low age value, it means it is the most recent LSA. And checksum value can also be calculated. I mean, recent checksum value will always be preferred. Recent checksum value will always be preferred. Exactly. First of all, it will check sequence number, then it will check checksum, and then finally it will check its age. So if you receive any update with higher age, then also you will discard it.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.